IT security, and I would like to talk about state-of-the-art logging. Well, I will talk about logging, but it's not about cutting trees. It's rather about syslog, and I will also talk about syslog-ng in particular, as Monolith IT security is developing it. I will also talk about freeform log messages and how they compare against name value pairs and structured logging. Of course, I can't avoid talking about the journal, which is a new buzzword right now in the logging world. I would like to talk about some standardization efforts, the CEE and Lumberjack, and at the end I would like to give a short demo of name value pairs using ELSA. So what is logging? In short, it's recording events on a computer, and the related thing is syslog. Syslog refers to many different things. It's an application. This is the application which collects events on the computer from other applications, but it's also a networking protocol which forwards these events from one computer to another, usually to a central location. So what is syslog-ng? It's a next generation syslog server. At least it was definitely a next generation when it first appeared 14 years ago, compared to the traditional syslog daemons. And it's also referred to as a Swiss Army knife of logging. Why we say this? As syslog-ng has a lot more input sources than traditional syslog, not just files or not just dev log or network, but also files, sockets, pipe, and many other sources. Traditional syslog can filter only on priority and facility of syslog messages. Syslog-ng can also filter based on message content, and can also combine these filters using Boolean expressions. Thank you. Syslog-ng can not only store and forward messages, but also process them. It can rewrite messages if necessary. It can normalize, correlate, and do many other things to log messages. And it also has a lot more destinations than traditional syslog. It can not just write files or send UDP datagrams, but also store messages to databases or send messages securely over an encrypted network. One of the still most widespread version of syslog-ng is 2.0, but it's end of life already for a couple of years, but it's still used in Debian, in SUSE Linux Enterprise Server, and in other distributions. So one of my missions is to introduce new features of syslog-ng, what happened since this major and important version. And one of the first is PatternDB and CSV message parsing, so we can see inside the message and analyze it. We can correlate messages. SQL and MongoDB destinations were also introduced after version 2. We have no JSON formatting, so name value pairs can easily transfer now over the network. And syslog-ng is now multi-threaded, meaning much better performance. The upcoming version is 3.4, which also adds JSON parsing, and configuration was already a lot more flexible than in any other syslog implementations, but it has quite some features, configuration, format changes to make it even more flexible. On a traditional Linux or Unix systems, most logs are stored under the var log directory. Of course, not all of the messages are coming from syslog. WTMD is coming from Login and it has a binary file there. Apache has the access and error logs there, but most of the files here are coming from syslog, which are in practice huge text files with many lines in it. Each line consists a date, a host name, and some text. Here is an example. This is from an SSH login. The text part of the log messages are generally some a proper English sentence with some variable parts in it, which makes it quite easy to read for humans. And on a workstation where there are just a few logs, it's very easy to find information this way. Just scroll a few pages of logs and one can easily find anything. On the other hand, on a server when there are a lot of logs, these free-form text messages make finding information quite difficult. The relevant information in messages is presented quite differently by each application. So let's consider that I'm called Peter, so my login name is Peter and the host name of my machine is also Peter. Then it's quite difficult to find all the relevant messages when there are a lot of logs. For example, if I only interested in messages related to my username. It's also quite difficult to process these logs with scripts. The answer for this problem is to use structured logging, which means that events are represented as name value pairs and not as free-form text. So we know that this field is a username, this field is a host name, as source IP or destination IP, which makes quite a big difference. In syslog-ng, we have a workaround or solution. It depends on where you look at it. It's called PatternDB. As I mentioned, log messages are usually some static text with some variable parts in it. So one can parse these messages in our case it's called the pattern-db parser, and this can extract useful information from the log messages and put this information into name-value pairs. It can also add status fields based on the text message. For example, it can, from a SSH login, it can extract the username that, for example, it's root. It can extract that it's a login action, and as these are static texts based on the text message, it can also give a status to the name value pairs that it's a fail. For example, it's a login failure. Of course, it doesn't work without patterns, and we have some, but not yet for all of the application and all of the log messages. Syslog-ng was based on name value pairs inside long before pattern-db arrived. Thus, one of the features Syslog-ng was popular was that it could store messages to different files based on reception date or application name or host names, and these were stored inside Syslog-ng as name value pairs, and the actual message was just another name value pair from the Syslog-ng point of view. As I mentioned, there is a new buzzword in the logging world. It's called the journal, which is the logging component of systemd. It's built on name value pairs inside from the beginning. So one can send a simple message like in traditional logging, but also send to the journal any name value pairs defined by the application, and the journal adds some trusted properties to all of the incoming messages. This means that systemd can check what is the user and application name and so on of the sender application. So applications cannot fake this information as can be done by traditional logging, but all of the important information can be collected. And one of the best things of the journal is that it has native support for name value pairs from the beginning, also for storage. Syslog-ng did not have it. One of the most frequently asked questions about the journal on the Syslog-ng mailing list or anywhere I go and talk about Syslog-ng, that is journal the enemy, as it's new logging solution, and so people think that it's our enemy, but we have a very short answer: no, it isn't. Of course, I have a bit longer answer too. Journal is limited to Linux and systemd, and even recent Linux releases don't have yet the journal. So, and Syslog-ng has a lot more coverage. It runs on all Linux distributions. it also runs on all the BSD systems, and we have also packages for most commercial Unix variants. So Journal is just a small part of it. Also, Journal is a local-only solution, so it works nicely on a standalone workstation, but it cannot forward logs to a central location, which is important in a network environment. On the other hand, Syslog-ng has a client-server architecture from the beginning, and it is mostly liked in network environments. Also, the Journal doesn't filter or process log messages, just stores everything it receives in some binary files. So, as we can see, Journal and Syslog-ng don't compete, but complement each other. Logs collected by the Journal can be forwarded to Syslog-ng, and once Syslog-ng received them from the Journal, it can filter, process, or forward them just as usual. And we are also working together with the systemd guys, so hopefully in the near future we will also be able to use Journal as a storage, as it's quite convenient. It has support for name value pairs, and there are also some utilities developed to show the content of the Journal with some GNOME applications. Journal, Syslog-ng, Windows Event Log, rsyslog, audit-d, and so on. These are all based now on name value pairs. But there is a huge problem. All of these applications and platforms use different field names in name value pairs for the same information, and also have a different set of information they collect. So this makes standardization a must, and this is why the command event expression was established. This is a standardization group established by MITRE, a US government organization, and Balabit and rsyslog and many other companies and individuals participate in it. It considers events as name value pairs instead of free-form text from the beginning, and it has a taxonomy which describes events in a standardized way, like status of the message or the action of the message. So it's not the application name or a free-form text which describes what is going on, but some standardized fields. So it's actually a lot more easy to correlate messages than when we need to consider free-form messages. And it also has a dictionary, so there are name value pairs which describe the parameters of an event, like a username, a source IP, destination IP. So these don't have different field name for each implementation, but a common dictionary. On the syslog-ng side, pattern-db can be used to turn free-form messages into CEE messages. One more thing related to cutting trees, it's Lumberjack. It's a project coordinated by Red Hat. No standard is good without an implementation, and the Lumberjack project was established this February in Brno at the Fedora developers meeting to implement CEE, so this standard could actually be used. It's coordinated by Red Hat, but it's a lot more open than the original CEE effort. Of course, Mitra, syslog-ng, rsyslog participate, but also a lot more individual security guys from around the world. It's open, and it has a very high traffic mailing list, and as it's done by Red Hat, the website is on Fedora hosted. One of the first tasks we try to implement is an easy-to-use API, so structured logging could be made easier. As far as I know, the first version of it was released earlier this week. It's the 0.1 version, but it's already possible to use it to override the syslog call in C, which means that if somebody uses this library using preload or linking to it, then all syslog messages are sent in a JSON formatted message, and it has the original syslog message and a couple of more information like user ID, group ID, and stuff included. And of course, there is an ongoing work on a common dictionary taxonomy and on solving the related transporting issues. At the end, I would like to show name-value pairs in action. I will use ELSA for it. ELSA is not a nice woman here, but it's an acronym standing for Enterprise Log Search and Archive. This is a nice application based on syslog-ng, pattern-db, and MySQL. It has a simple and powerful web interface and has extreme scalability, even outperforming many commercial applications. It can receive and
what do you call extreme? How many bytes per second?
up to 100,000 messages without message loss and indexing.
What about volume size?
Sorry?
What about volume size? What about the data set? How big does your data set go?
Sorry?
How big does your dataset grow?
I know in installations with 40 to 50,000, 40, 50 terabytes of data, login data, and used by ERSA with search speed like 1 second or 2 seconds, just like Google. So, that's quite nice, I think. It's developed by a networking security guy at the university, so the patterns included with ERSA are related to Cisco firewall messages, SNOR, HTTP, different intrusion detection and prevention systems. So my example is oh, sorry, I thought that it will be better, easier to read. My example is HTTP, which probably isn't the best example as it's already partially structured, but that was what I had parsers for in ERSA. Here we can see that here is a log message with bold letters. That's what arrived to syslog-ng, and below that we can see it parsed by ERSA into fields, source IP, destination IP, and content and or method like get or put, and the status code of the HTTP. So it's parsed, and it can be any of these fields can be easily searched in ERSA. It can also be put into a nice diagram like 200, 404, and so on. And my favorite new feature in ERSA is what is called transforms by the developer. It's actually a feature making possible to further process the search results. So I have some search result from the HTTP logs, and there are many different filters. For example, what I like to use is WHOIS, so it can access the WHOIS database and search which ISP belongs to a given IP address, and then this result can be further processed. For example, what we have here on screen, some query in the HTTP logs, then processed by WHOIS, and then a grep. So then at the end, a grep finding a specific ISP from these logs, which is quite difficult to do if our logs are not processed, and we don't know if it's a source IP, or we don't know if it's an IP address at all in the message, or we don't know if it's a source IP, destination IP. With PatternDB, all these are in different fields, and we know what field what is what, and we can search and process it. So this was it, and I would like to know if there are any questions.
The filters you mentioned in ELSA, are they written in a standard format? Are you
Sorry?
thinking about the filters in ELSA? Are they in a specific format?
These are more like plugins. So there is a Whois plugin, or it has plugins for CVE, or so.
Because the guys from Logstash are doing filters, Splunk is doing filters, there's a bunch of people rewriting the same filters. Maybe there would be a GitHub repository somewhere with usable filters that can be used in Ultimate. That would be really handy.
Actually, ELSA was inspired by Splunk, just with a little difference that it's all GPL. And with Splunk, if you have more than 500 megabytes traffic a day.
There's Graylog too, there's Logstash. I mean, to me Splunk is relevant, but this is just the third competitor in the area.
I used Logstash, and I know by experience that it doesn't scale so much as ELSA, and also it doesn't have access control like ELSA has. ELSA can authenticate with LDAP or Active Directory or UXPAM.
They then define different ways of access control based on this user can only see these kind of.
Yes. So it's of course ELSA is also a niche. So it's concentrates on networking security, which it doesn't have, for example, what would have been a nicer example to use here is login logout actions, but the number of patterns in ELSA is growing every day, so hopefully it will be completed soon. Any more questions?
Yes. Most of distribution now install rsyslog and not anymore syslog-ng or syslog. Do you think is a good idea? Because you don't talk about rsyslog in your talk.
Yes, rsyslog is installed by default in most, but not in all the distributions. We don't see it as a problem. The reason is that as long as something is installed by default, nobody cares that it's there. So rsyslog will be replaced by the kernel in many distributions this year, at least in Fedora, in OpenSUSE, and a couple of smaller distros, and nobody will notice the difference. On the other hand, when somebody starts to look at logging a bit more seriously and is conscious about doing logging, then we'll look at the differences, and I know that most of our user base is coming from Red Hat and CentOS, and the default logging solution is rsyslog there, but they are replacing it with syslog-ng as soon as they are looking at logging consciously. So,
small question. With rsyslog, we also replace rsyslog with syslog-ng, but we still use SEC, Simple Event Correlator, do some filtering. But I probably missed this feature because we're running the old version. The new correlation engine in syslog-ng. Can I set it up to do, like, for example, X failed logins within X amount of time, sort of correlations?
Yes, it can, but correlation is quite a new feature in SysLogNG, so it's not yet in widespread use. So there are some people already using it, but
It's under development.
yes.
You mentioned the graph with the HTTP example where you have your 200 requests and your 404s. Is it possible to get triggers on those? As if your amount of 404s today is 50% higher than say yesterday to find events like that?
As far as I can remember, yes, but I used the alerting feature quite a long time ago, so I don't remember the exact part of. I rather use it just for searching logs, not for alerting. So I'm not 100% sure about it. Any other questions? Yeah, thank you for your attention.